All right, just to review for you, we've got a couple things. I'm going to sort of show you like a little proof, and I'll just run through it quickly. You obviously aren't going to need to prove things. Just I want to establish that these are facts for you, and you can use these facts. So do you guys remember from your geometry class, if I have two parallel lines, right? What's a line like this called? Do you remember? Starts with a T. What's that? Trans something.
Wait, what is it?
Transversal, right? Do you remember that?
Are you kidding me?
I don't think you taught me that.
I never remembered that before.
Transversal lines?
Okay, spit that coming to my mouth now.
Guys, Eli, stop. Pay attention.
You like them orange comments?
What's that? So this is a transversal. What do we know about transversals? What do we know about the angles that are made by a transversal line? Stop talking, guys.
We are not talking, we are just laughing.
Pay attention. What do we remember about the angles that are formed by a transversal line crossing two parallel lines? Anybody?
I have no clue.
I don't even know what you said.
Have you seen this before in your last math class?
No.
What do you know about the angles that are made? What's that?
Supplementary.
Yeah, what are supplementary? I'm sorry, what'd you say? Yes. Supplementary angles form
180.
180 degrees.
Complimentary 90.
Very good, very good.
I know.
What about do you remember like alternate or same side? Do you guys remember anything about that? Angles, corresponding, that's a good one. What do you remember about that?
Same side.
Same side, yeah.
Each other.
So corresponding angles are congruent. Basically says that if I go clockwise from here, if I go like actually I'm going counterclockwise. 1, 2, 3, 4. And I do the same here. 5, 6, 7, 8. 1 corresponds with 5. 2 corresponds with 6. 3 corresponds with 7. And 4 corresponds with 8. And these are the same. So 5 is the same as 1. 2 is the same as 6. 3 is the same as 7. 4 is the same as 8. Also, what do you remember about vertical angles? Do you remember that?
Angles are all facing 2 and 4.
Good. Yeah, 2 and 4 are vertical angles, so those would be congruent, meaning they have the same measure.
Are they opposite of each other?
Yeah, the kind of opposite of two crossing lines. So 2 and 4 are vertical angles, and they're congruent. 1 and 3 are vertical angles, so they're congruent. And if 1 is the same as 5, that means 1 is the same as 7, and 3 is the same as 5. And that allows us to establish this thing about 3 and 5, also about 4 and 6, that we would say alternate interior angles are congruent. You can also say that same side interior angles are supplementary, because 5 is the same as 1, 4 is the same as 8, and 1 and 4 make 180 degrees, 5 and 8 make 180 degrees, therefore 5 and 4 make 180 degrees. Is that okay? So from this, if you draw, I'm gonna draw a line that's perpendicular to my two parallel lines, and that allows me to make a right triangle. So from this, I know that that 3 and what's left here, I'll call it A, are going to have to be complementary. 3 and 5 are the same, therefore 5 and A are also complementary. So those are some of the facts that we can establish about right triangles. I'll just draw a generic right triangle. We know that the two acute angles, the two angles that are less than 90 degrees, are, I'll call this A, B, and C, those angles.
D,
We only have 3.
E.
Angles A and B are complementary, so they're going to add to 90. The other angle is 90. Triangles have 180 degree sum for their measure of the internal angles. Hopefully that's all familiar to you. Now we have a convention, Eli.
Because if they just want to stick a shower for 2 hours, like how do you have that much hot water? Like, I'm jealous.
That is something to be jealous of, but pay attention, please.
We are paying attention.
You're
We're
talking,
literally talking about acute angles.
right?
Exactly. So I'm
The
paying
angle
attention.
of
What
the
I
shower
say about them?
is
What?
acute
What I say
to
about
the
them?
obtuse of the top.
Whenever you say what, it's like giving yourself time to think.
What?
English, please?
What did I just say about acute angles?
What did you say about them? That they're the smallest angle possible, and they're little cuties.
That's not
Like Sophia.
anything
What?
close to what I said.
Under 90 degrees, baby.
Baby girl.
I said the two acute angles will add to 90, the other angle's 90. Altogether, you have 180 degree sum for the measure of your internal angles in a triangle.
And that's exactly what I said to Cody.
Yeah.
No, you went.
He was whispering. If I hear that whole freaking time.
No, you went.
Okay, pay attention here, okay? You know how
Paying attention.
if I have a flashlight and I shine it at a wall,
Why would you do that?
just listen,
Just to see the wall, Eli.
maybe.
Honeydew.
Or maybe I'm making a point about triangles. If I turn on my flashlight, right, and I shine it at a wall, it makes a spot, right?
Yeah.
If I have a wider angle light, right, flashlight, I'm going to make a bigger spot. And if I have a smaller angle flashlight, I'm going to have a smaller spot, right?
Yeah.
You have an angled flashlight.
Yeah. That's.
The angle of the beam,
Yeah, who's not?
right?
Oh.
I got circular flashlights.
Like the angle of the light.
I don't really have a triangle flashlight. to
Like
be
this, like
honest.
this, like this. They're parabolic inside, but they come out like so. You could have one like this. Or you could have one like that, right?
Yep.
The smaller the angle,
I'm gonna be honest.
the
the
smaller the spot.
My flashlight is not triangle. It's more like a circular.
No, that's like the
That's like the handle color, where you hand it such a big long shaft.
Are you talking about the light?
Actually, inside of the flashlight, it's usually a parabolic shape.
it's kind of
Because
like a cone, but like inside out.
because if you have a light source at the focus of the parabola, then it should reflect to go out straight outward. So they're typically parabolic lenses. At least that's the attempt. Okay, so every angle has a side that's kind of paired with it. So opposite to angle A is side little a. So you can think of it as like you have a light in that corner and it shines onto the opposing wall. So angle A goes with the side A that's opposite to it in the triangle. Angle B opens onto side B that's opposite to it, like a light would shine onto a wall. And angle C, the 90-degree angle, guys, Eli, stop. Stop. The 90-degree angle, angle C, opens onto the longest side as it's the largest angle. So you call that the hypotenuse. And that's the little c. So when I draw a right triangle like this, what do you guys think of? What do you guys remember from your previous class? See my drawing of the triangle in the bottom left? What jumps out to you? What do you think of?
I think of dinosaurs,
There's
because
such a gnarly glare on your TV, bro.
Is there
Oh, yeah.
just on one side?
all the.
On the left side, like,
All right, I will redraw it. I'll draw it slightly differently over here.
yep, that's perfect.
I'll draw the same thing, I guess.
Yeah,
So the idea is that,
Can I
The-
go bathroom?
yes, the angle A opens onto side A like a flashlight would shine onto a wall that's opposite to it. B goes with B and C goes with C. When I draw a triangle like this, does anything jump out to you that you remember from your previous math class? Any relationships or,
the triangle kind of looks like Phineas. Phineas Bird.
maybe? Something from your
This
class?
just looks like normal, like geometry.
That's like normal stuff that makes my brain.
Any equations, any formulas or,
Pythagorean theorem.
very good. What was the Pythagorean theorem?
A squared plus B squared equals C squared.
Good, so that's one of the ones that you will use.
That's about now.
Wait, what do you mean one of them? This is something that you have to like choose what.
Yeah.
Oh my goodness, Mr. Chappelle.
Yeah, this is called solving triangles. And so you have three angles, you have three sides. With right triangles, you know one of the angles is a 90-degree, so that's given to you. But solving triangles is taking information about some of that and figuring out what the rest of it is. That's called solving a triangle, figuring out what all the sides and all the angles are, given a limited amount of information. Okay, so we have the Pythagorean theorem. Shh. Pay attention, you guys. I'm going to start the drawing over. Okay, so we have a squared plus b squared equals c squared. From this, we can identify if a triangle is a right triangle. If its sides, when you square them and add them up, make the square of the longest side, the hypotenuse, then it is a right triangle. If it fits this equation and makes it true, it is a right triangle. So you can check to see if your triangle is a right triangle with this formula. We also have what are called special triangles. Does anybody remember any special triangles from geometry class? No,
Obtuse triangle.
there are obtuse triangles. They look like this, right? They have an obtuse angle
Yes, sir.
and two acute. You have the right triangles, which has one 90-degree angle and two acute. And then you have an acute triangle, which has all acute. That's true. You also have, the equilateral triangle, the isosceles triangle. What's the other one? Scalene, where they're all different. But we had some special triangles. These were right triangles, so they're all right triangles. But we called them special triangles, and you were expected to memorize the relationship between them, between the sides. Does that ring a bell for anybody? Okay, I'll give you one of the special triangles. We have the 3, 4, 5 triangle. Does that ring a bell?
One.
The 3, 4, 5 triangle? Anybody remember that one? The 3, 4, 5? No? So you have, let's say,
20 angle, 30 angle, 40 angle.
you're getting warmer. Yeah, we had two special triangles in terms of their angles, two special right triangles. Remember, they have to add up to 180. Does anybody remember special triangles involving angles? Not quite, because that'll look like this. That'll be 60, 60, 60. So not a right triangle. That is a good triangle to keep in mind. Those have equilateral, so the sides are the same, and the angles are the same. One of the special triangles has, one of their acute angles is a 45. Yeah. It's not, so we're only stuck with right triangles here, okay? So one of our special right triangles had 45 as one of the angles. What were the other angles? One has to be 90.
One's 30, one's 60.
The other two have to be 90 as well when you add them up. If one's 45, the other's got to be 45 too, right?
Yeah.
Do you guys remember, like when I say 45, 45, 90, does that stick out in your mind? It does? It's an isosceles. So you do have a 1-to-1 relationship between the two legs. The hypotenuse, these are ones yours to memorize. Relative to the shorter leg, it's square root of 2 times larger. So if you had, yeah. Yes, you may. Did you need to go, Sophia?
Lauren,
I had to go.
So this is one of your special triangles, the 45, 45, 90. And so you always call the smallest side 1. So in our special triangle, we would say the legs are each 1 because they're both the same size. And the longest side would be square root of 2 times larger. And you'll see that it fits the Pythagorean theorem because 1 squared plus 1 squared, that's 1 plus 1 makes 2. So root 2 squared is 2, so that fits.
Thank you.
You made it.
He's taped up to the stuff.
How are you? We're going over triangles, Ethan.
Doing what?
Going over triangles.
Oh, alright. That's cool.
So we're going over right triangles. That's what we're starting with. Those are the easiest ones to work on. And I was hoping that maybe you guys remember some of that from geometry. We just went over the Pythagorean theorem. So a squared plus b squared equals c squared. That's true for right triangles with a 90-degree angle. We covered that in all triangles, the angles inside add up to 180 degrees. And if they're right triangles, so one of them's a 90, that means the other two have to add to 90 as well to make 180. So we had 2 special triangles when it came to degree measures. One of them was the 45, 45, 90 triangle. And one of them was the 30, 60, 90. You guys remember that one? So you have a small angle, you have an angle twice as big, and then you have a 90 degree in the corner. The smallest angle is always opposite to the smallest side. The middle angle is opposite to the middle side, and the largest angle is opposite to the hypotenuse. These will have 1 for the smallest side, root 3 for the, kind of messed that up, root 3 for the second largest side, the other leg, and 2 for the hypotenuse. And that fits the Pythagorean theorem because 1 squared makes 1, root 3 squared makes 3, and 1 plus 3 makes 4, which is 2 squared. So There should be a triangle assignment down at the bottom. Should be a new block called triangles that you can expand. Is that correct?
I don't see it.
Yeah, try refreshing. What does that block say down there?
Modeling.
You don't have a triangles? Let me see. Did I do it to the wrong class? Maybe I did. I guess I did. Let me copy it. My courses. Those are two. That's not it. It's this one. There we go. All right, now refresh and hopefully you have it. Did I say Wednesday? Yeah, it should be right now, right? This is open?
I'm using late pass for this.
You shouldn't. Why did I do it at 9? It's like it was the test or something. Let me change that. 8. Oops. P. How about now, if you refresh? I'll do this one now, so if you want to go to it, you can. So only the right triangles is for today. Oh, right triangles 1. What? Oh, well, anyway. There it is. Okay, so you have your special triangles, and those are the relationships between the sides for each of the special triangles. What you're mostly going to use is either the Pythagorean theorem or one of the trig functions. So I'll write a squared plus b squared equals c squared. That's formula 1. I'll draw a little triangle here. And then we have the trig functions, which are sine. And then we have cosine and tangent. And for a right triangle, these are going to be the opposite side divided by the hypotenuse. The adjacent side divided by the hypotenuse. And tangent can be thought of as sine divided by cosine, which is opposite over hypotenuse divided by adjacent over hypotenuse. And when you have that, the hypotenuses can cancel. So that's the same as just opposite over adjacent. So if I was looking at angle A, I would say that sine of angle A is equal to, the opposite is little a over c. And for cosine of angle A, it would be adjacent, so little b over c. And for the tangent, it'd be a over b. Whereas if I was looking at the angle of B, I would have opposite of B is little b. Cosine would be a over c. And tangent of angle B would be b over a. So it's dependent on which angle you're looking at. What's considered opposite and what's considered adjacent. So one thing you'll notice is that in part 2, where I have these different trig ratios, they're called. They relate two sides in one angle. So when you're solving an equation, you can only have one unknown. So if you want to find a side, but you have another side in an angle, you can use one of the trig ratios. The Pythagorean theorem involves three sides. So to find one of the sides, you would need the other two. On top of that, you have the piece of information, I'll do number 3 over here, I guess, which is that angle A, the measure of angle A plus the measure of angle B makes 90 degrees. So altogether, that's what you're going to use, those three pieces of information. You have the Pythagorean theorem, which relates three sides. You have the trig ratios, which relates two sides to an angle. Each of them does. And then you have the piece of information that these two angles are related to each other. They have to add to 90. So using those pieces of information, you can solve triangles. So we'll go through some of the questions on the homework. A lot of them are very similar. And the next homework that I made, Right Triangles 2, is also very similar. It's pretty much the same type of questions. I'll just give you a reminder of them next class. All right, so they say little a here is 7, and little b is 5. All right, so we can figure out, oh, I haven't mentioned these guys. I didn't realize they were going to ask that. How many of those involve those guys? Some of them. I'll mention them now when I do that problem 1. Okay, so that's a slight complication. All right, so hopefully you remember from geometry. Oh, I'm sorry, I skipped question 1. Okay, so the angle of elevation from the top of a building in New York is found to be 3 degrees from the ground at a distance of 2 miles from the base. They want to know the height of the building. What is the angle of elevation? Do you guys remember that from geometry? There was the angle of elevation and the angle of depression. So if I have a building and I'm 2 miles away, the angle of elevation is, if you tilt your head to look up, and they're saying it's about 3 degrees. When you're 2 miles away, I kind of did too big of a building here. But this is called the angle of elevation. If you were up high looking down, so if you're looking straight out, but you look down, this part here is called the angle of depression. So those are the terms for that. So if this is 3 degrees and we're 2 miles away, we want to know the height of the building. So I have an angle. I want to know the side opposite to it, and I have the side that's adjacent to it. So I want to use the trig ratio that relates opposite to adjacent and the angle. So that means tangent of 3 degrees will equal the height divided by 2 for 2 miles. Now that means height is going to be equal to 2 if I multiply 2 on both sides. Height is going to be 2 times whatever the tangent of 3 degrees is. So one thing you got to make sure is on your calculator, when you turn it on, you should see a little symbol somewhere on your calculator. Mine says DEG down at the bottom, which stands for degree mode. There should be a button on your calculator to switch modes. For me, the button says DRG. So if I press that, I can switch from degrees to radians. I want to be in degree mode. So I'm just going to say 2 times the tangent of 3. And I get the height to be 1.05 about. I'm sorry, 0.105. And that's in miles. So that's what I put in for number 1. Oh, they want it in feet. So you're going to have to multiply. Anybody remember how many feet are in a mile?
5,280.
Yes, it is, yeah. 5280. If I multiply that by my 0.105 miles, I do get 553.4621492, which is what they have, so that's good. I think almost all of these have videos that go along with them, so you can utilize those. Let me just mention now how to do number 2, because they involve these other trig ratios that I haven't mentioned yet. Basically, these are just the reciprocal of the ones that we know. So cotangent is just the reciprocal of tangent. So instead of opposite over adjacent, this would be adjacent over opposite. Secant, it starts with an S, but it's actually the inverse of cosine. So if cosine was 1/3 or 2/3, then secant would be 3/2. Cosecant is actually the inverse of sine, even though it starts with a C. So here we go. So we have A is equal to 7. B is equal to 5. All right, so we want an exact answer or at least 2 decimal places. So I need to find the hypotenuse. So if my 2 legs are 7 and 5, I have 2 legs, I need a third, so I need a relationship that connects 3 sides. So that's going to be the Pythagorean theorem. So 7 squared plus 5 squared is 74. The square root of 74 is 0.86023. So you can just use the square root of 74. So for sine of A, I would go opposite over hypotenuse. So opposite is 7 over the square root of, what did I say, 74? Let me check that again. Yeah, square root of 74. It'll take that. They're just rationalizing the denominator. Cosine will be adjacent over hypotenuse, so that's be 5 over the square root of 74. Tangent will be opposite over adjacent, so that's 7/5. And for the other ones, for secant, you're just going to flip cosine upside down. Yep. And for cosecant, you're going to flip sine upside down. And for cotangent, you're going to flip the tangent upside down. Whoops, I accidentally pressed enter. That should work. Question 3, I think we're going to have to draw a picture.
Can you go back to like question
2, you said?
Yeah. Like, is there like anything? So, is there like anything on like calculator that does like the bottom 3 little things?
Those 3?
Yeah, you have to figure out for yourself.
It's just these ones that you flip upside down. So are you getting them as decimals or what are you getting?
I put them in decimals.
Did you get the first three right?
Well, I don't remember.
Okay, one thing you could do, so if I do 7 divided by the square root of 74, I get like 0.813733471. On my calculator, I have this inverse button, which is like x to the minus 1. You might have 1 over x. So if you just take the inverse and press enter, that's the same as the reciprocal. So I could have done that. Does that help you?
Yeah.
So secant is the inverse of cosine. Cosecant is the inverse of sine. So don't confuse those.
Alright.
Did you get it?
Yeah.
Good. All right, number 3, I'd always recommend drawing a picture. So we have a radio tower. It's 275, whatever, feet from a building. The building, there's a window in the building, and a person determines that the angle of elevation to the top of the tower. What? Wait a second. Okay, there's a building and a tower. Okay. So I'm going to draw a little tower and a building. The person is in a building window, and they look up to the top of the tower, and they make an angle of elevation of 43. And the angle of depression to the bottom of the tower is 27. How tall is the tower? Okay, so let me draw that for you. This one's kind of involved. So I've got a building with a window in it. I'll just do a small window. Let's say this is the window. This is the guy's head in the window. And then there's a tower. Tower's here. Well, the guy is here. Okay, the angle of elevation to the top of the tower is measured from the straight line, and they said that was 43 degrees. The angle of depression to the bottom of the tower is 27 degrees.
It's just gone.
Yeah.
I go to the back.
Yeah. So I need to calculate, I've got 2 triangles here, 2 right triangles. And I need to calculate the height to the top and the height to the bottom. So I'm going to set up 2 different triangles and solve them that way. Now they told me that the distance between the building and the tower is 275 feet. So my first triangle I'm going to draw looks like this. Height to the top, 43 degrees, 275. So from 43 degrees, that angle, I have an opposite side and an adjacent. So I'm going to use tangent. Tangent of 43 degrees is equal to height to the top over 275. My other triangle, I'm going to go ahead and flip it upside down. I'll call this height to the bottom. It's 27 degrees, and it's also 275 base. So I'm going to do the same thing because it's opposite or adjacent. So I'm going to have tangent of 27 degrees is equal to height to the bottom divided by 275. So for the first height, I'm going to take 275 times tangent of 43. And for the second height, I'm going to take 275 times the tangent of 27. Then I'm going to add those two heights together. Height to the top, I got 256.442. Height at the bottom, I got 140.119. And if I add those, I get 230. I'm sorry, 396.561-ish. Let's call it 56. All right, so 396.56. There we go. Is that one okay? For number 4, we have an angle and a side. So we want to find the other sides. So I have a triangle. Side A is 3, and angle A is 70. I want to find B. So angle A would be related to A and B as opposite and adjacent. So that's going to be tangent. So I'd say tangent of 70 is equal to 3 over B. That means I can think of tangent of 70 as tangent of 70 over 1 if I want. And to get B, well, I guess, you know what I'll do instead? It's kind of like cross multiply. I can flip this position of the B and the tangent of 70. So I can bring the B up to the left and the tangent of 70 down to the right. So I would get B is equal to 3 over tangent of 70. And that should give me about 1.091912. I don't know how precise I need to be. There we go. So we're just going to use the trig ratios for that. For C, besides C, I'd probably use sine of A because that's opposite over hypotenuse. So sine of A is equal to 3 over C. So 3 divided by sine of 70.
Can you go to the back?
Yeah. Is 3.1925. And angle B, I know has to be 20 because angle A is 70 and I know they got to add to 90. Any questions on that one? Five works in a similar way. All right, if I had angle, for question 6, if I had an angle and I had the side opposite to it, and I had the side adjacent to it, I'd have to pick which function relates an angle to its opposite and adjacent side. That'd be tangent. So that's what I'd use to solve that. Number 7, the fraction, no decimals. If the answer involves the square root, be entered as square root, for instance, blah, blah, blah. Okay. All right, so this one, I have a tangent, which should be opposite over adjacent. So let me draw a picture for you. Tangent. I figured out that I got to go left. Let's see, 5/3. Okay. So let's say this is my angle. Tangent of that angle is minus 5/3. That's opposite over adjacent. So one of these has to be negative. They told me that sine of theta is greater than 0, so it's positive. Well, sine is opposite over hypotenuse. So if 5 over c is positive, that means the negative has to go with the 3. That way, the cosine will be negative. The tangent will be negative, but the sine will stay positive, because that's 5 over c. So then I can figure out the other things. The sine is whatever 5 over c is. Cosine would be negative 3 over c. Tangent we already have. Now let's see what else. C would be whatever 25 plus 9 is. Which is 34, square root of 34. That'd be C. Yeah, 5 over square root of 34, 3 over square root of, negative 3 over square root of 34. This is the inverse of cosine, so it'd be square root of 34, negative square root of 34 over 3. This would be inverse of sine, so square root of 34 over 5. And then cotangent is the inverse of this one, so negative 3/5. So once you get the basic ones, you just flip them upside down, and that's how you get the other ones. Just remember the secant, even though it starts with S, goes with cosine. It's the flip of the cosine. And cosecant, even though it starts with a C, is the reciprocal of sine, which starts with an S. So try to keep that in mind. It's opposite of what you might think. Okay, we got a triangle for number 8. ABC. Cosine of A would be opposite over, adjacent over hypotenuse. So that should be 7 over 11. This one, they want you to find the angle. So I'll do question 9. We're missing an angle, but we have an opposite side and the adjacent side. So that we're going to use tangent. So this is how you find an angle. Tangent of an angle equals 14 over 11. So what is the angle? Well, the way that you undo a trig function, like tangent of something, is to use the inverse function. So we're going to use inverse tangent on both the left. And we have to do the same thing on the right in algebra always. So the inverse tangent will undo the tangent, and that'll just give me theta on the left, the angle. Whereas this is something I can put into my calculator, inverse tangent of 14 over 11. Another name for inverse tangent is arctangent. Those are the same thing. So depending on what calculator you have, it might say one or the other. Those are the same. Make sure you're in degree mode if that's what you want. And I get 51.843 or 28, depending. Which is correct.